So for the next few weeks, I'll be discussing this JAM paper of 2024, 3 problems at a time in full detail so that you understand the concepts behind it, not to rush through it and just tell you the solution and the options. That's not the way Cheenta follows, okay? We have a different strategy of learning for a long-term learning future, and that's what we will stick to, that's what we will follow.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
This is another interesting problem. Problem number 6 from 2024. X is the continuous random variable with having the uniform minus 2 comma 3 distribution. Then which of the following statement is correct? Let's see. So by uniform minus 2 comma 3 distribution, you have, let's say, minus 2 here and minus and 3 here. Minus 2 and 3 here. So, and if you remember the PMF of uniform, you will see that this like this, it's like this. So this is the Y, this is a PDF, I'm so sorry, not PMF, and there here it's 0 onwards. This is the PMF, a PDF of uniform minus 2 comma 3. Okay, and of course the height, the length is 1 point, the length is 5, the area under the curve will be 1, so therefore the height is 1 by 5. Okay, because the area of the rectangle is length into breadth. So now what is happening is that each of this individual x is being transformed to a new number. In the first case, x is transformed to 2x plus 5. In the second case, x is transformed to 7 minus 6x. In the third case, x is transformed to 3x squared plus 5. And in the final case, x is transformed to mod of x. Now the question is that after each of these transformations, okay, imagine that uniform distribution is nothing but a uniform set of points on an interval. Okay, if you close your eyes and randomly pick up a point or a set of points, an interval of points, if the interval is same size, the other, imagine like you have an interval and you have a small bucket, you put that on the interval, and the probability of getting the numbers in that's whatever you get is always the same wherever you put. That's the basic idea of uniform, because it's uniformly same everywhere. Okay, so the question is that after this transformations, will it stay uniform? And if it stays uniform, then uniform on which interval? These are the two parts of the question that it's asking. Again, I'm repeating. After each of these transformations, will the distributions remain uniform? If it's uniform, then on what interval it is uniform? Okay, all of you got the question? Let's see. But before we continue, let's look into this simple example, mod of x. Okay, because it's the simplest one. Now your intuition says that, like, what makes it non-uniform? That's the main question, right? All of them are not uniform, right? Only one option is correct. So what makes them non-uniform? So let's take this simple example. Understand this very carefully. That here it's minus 2 and 3. Here is uniformly here. Now you have mod x. Now when you have mod x, what happens? Everything is transformed to this positive side. That means this transforms to 2. Everything, it's like this reflects. It's like this part goes to the other hand side. Okay, so all of them goes here. Each of them goes here. So naturally you can see that. So therefore the transformed region is that after mod x you're only picking up from 0 comma 3. Now let's say there are two parts, till 2 there is a part and after 2 there is a part. Now when you're considering this till 2, there's an interesting aspect. If you randomly pick up a point or you put a bucket inside this, the probability of mod x lying in the region is, let's say, probability of mod x lying in 2 to 1.9, right? If you consider this probability, this is two things. This can happen that actually x is between 2 and 1.9, but since x can take negative values, it also means that x can also be between minus 1.9 and greater than minus 2. Okay, but this doesn't happen after 2, right? Because x doesn't take less than minus 2 values. So when you take the positive of it, it will only lie between 0 and 2. So therefore you can understand that there's an extra weight, extra kind of um, distribution, extra chunk between 0 and 2 when you do mod x. So the uniformity is cancelled, right? It will become like, here it's a bit more between 0 and 2, till 2 it's a bit more, and then till 3, from 2 to 3 it will be a bit less, the chunk, the area. Okay, because minus 2 to minus to 0 has been transformed to 0 to 2, so there's an extra building up there. So that makes it, the distribution, it turns out to be non-uniform. It's not uniform over all the parts of that interval. Now how to show it mathematically? That's why this is a very simple intuitive example, right? But how to show it mathematically? Let's just, how to show this mathematically, that's the main question, right? This is how we do it mathematically. So we try to find a new random variable y. We want to find the PDF of the new random variable y. So it turns out to be probability y less than or equal to small y, and you replace it like, now you replace y by the equation, right? Let's say mod x less than or equal to y. Now you see that there are two aspects: y greater than 2 and y less than or equal to 2, right? This is very important to distribute a range, because you understood the change, the transformation. Because as I have told you, less than y there are two aspects, minus 2 to 0 and 0 to 2. But greater than 2, less than 2, there are two aspects, minus 2 to 0 and 0 to 2. But greater than 2, there are two aspects, there is only one aspect, 2 to 3. So if y is less than or equal to 2, probability mod x less than or equal to y has two aspects. Understand, it's 0, this is minus 2, this is y, this is minus y, this is 2, this is 3. So you can understand that probability x less than mod x less than or equal to y leads to two regions: x less than or equal to y and x greater than or equal to minus y. Okay, so therefore probability mod x less than or equal to y is nothing but probability x less than y and greater than minus y. Okay, for y less than or equal to 2. Now for y greater than 2 it will be different. For y greater than 2 it will be just probability x less than y and greater than 0.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.